Hello everyone, I'm Suhas, and I welcome you all to the NLP stream at ACE. I'm excited to inform you that we at ACE have embarked on the ACL 2020 Spotlight Series. In the coming weeks and months, we'll be inviting authors from all over the globe to come and discuss their ACL paper with our community. We already have exciting sessions lined up, including the winner of the Best Paper Award at ACL. Today, we are thrilled to kick this series off with Jeniya Tabassum from Ohio State University, who has done a lot of work on NLP, on user and noisy user-generated text. We'll discuss her paper at ACL on applying named entity recognition to the programming domain. Also joining us is Royal Sequeira, who is a freshly minted stream owner at ACE, so fresh that I can smell the mint. We will be seeing a lot of him at future NLP events. So, hello, Jeniya. How are you?
Good. How are you?
I'm good too. I attended ACL too, by the way. It was an incredible conference by all accounts, albeit a little tiring due to the constant Zoom call switching. Did you like the remote format of the conference?
Actually, I like it less than the in-person one, but considering the current world situation, I think it was awesome.
Hmm. Nice. I was just wondering if there is one paper that intrigued you and caught your eye and you want to share it with the audience, which one would it be?
There are a lot of interesting paper in the ACL, but one thing that was really interested seems interesting to me was the stance prediction paper named Predicting the Topical Stance and Political Leaning Using Tweets, and it was presented by Stefanov et al. So that paper was basically suggesting a distance supervision process to collect the tweets which can be anonymous tweets. So I wouldn't go into details of their paper, but the gist was something like that. You already know the event, then majority of the tweets about that event will be some kind of rumor. So just use the time window to gather all the tweets and then collect them. So that was a really interesting approach of collecting massive amount of data. So I really like that paper.
Nice, nice. What about Royal? I think you um, attended the conference too. Was there any paper that caught your eye?
Yeah, I attended the conference, and even before the conference, I was going through all the papers, and I really like not to jump on the bandwagon, but I really like the paper on. I think there are two papers I'm finding it a little hard to choose. One from Bender and Fowler on meaning, form, and understanding, and the second one is on checklist or how do you decide whether to deploy a model or not. So after some deliberation, I think the latter one is what I find more interesting because it's also related to the work I do at my company. And what was interesting in the paper, for example, is I think uh, the authors find out together how they found out that although many models like our claim that they show human like performance on or like better than human level performance on reading comprehension using behavioral testing you can still find out that there are very simple cases where the models fail and humans can do much better. So I think I would pick the checklist paper to be my favorite paper.
Nice. There are a lot of papers that I really liked. I'll pick one of them randomly. It's called location attention for extrapolation to longer sequences. So
Mhm.
basically, the context is that neural networks are not so good when the test set contains examples whose lengths are longer than the examples in the training set, and they generally struggle to extrapolate to lengths not seen in the training set. And the authors uncovered this fascinating thing. They show that sequence to sequence models internally keep track of a counter of when to output the EOS end of sentence token, and this feature hurts the model in extrapolating to longer sequences because the generation terminates early. And in this paper, they propose having separate location and content attention that can help with the extrapolation. Um, I think that's about it for ACL. I think we are all very keen to hear about Jeniya's paper, which is called code and named entity recognition for Stack Overflow. And Jeniya, would you like to present your paper
Sure.
now?
Sure.
Thanks.
Thanks for inviting me. I will be very happy to present my work. So basically, this is my work published in this ACL, and this is a joint work with my labmate Monica Madila and my advisors Alan Ritter and Veshu. So this work introduced a NER corpus with 15,000 Stack Overflow sentences that are manually annotated with 20 different entity types. To our best knowledge, this is the first corpus for fine-grained software named entities, and it is now publicly available at GitHub. To recognize these entities, we have also proposed a named entity tagger that is capable of extracting the fine-grained software entities with 79% F1 score. And thus, it provides an absolute increase of 21.6 F1 score over off-the-shelf fine-tuned BERT. This huge performance gain of our named entity tagger is particularly aided by the in-domain contextual embedding, which is extracted by pre-training the software domain Elmo and BERT embedding using 152 million sentences from the Stack Overflow archive. Now, the usual question is, why do you need to extract these entities from the software text? Actually, extracting these software-related named entities can be really helpful in different downstream tasks. For example, they can help the code retrieval system by identifying the programming language and code-related entities in the given natural language query, and then select the corresponding code snippet with the matching entities from the given code base. Further, it can be also helpful to create a software-related knowledge base by clustering together the entities from posts with similar tags. So finding such entities can be really helpful. However, the extraction of software-related named entities imposes some significant challenges. It is because the named entity tagger in software domain needs to resolve the polysemy and extract the inline codes from the text. Let's look at the polysemy first. Consider the word list. So if we just talk about the word list, we usually think it as data structure like Python list. However, the same list word is a class name if we change the language to Java. It can also be a variable name if the programmer names the variable list, as in this example, because programmers has the full freedom to name his or her variable or functions anything. List can also be non-entity when it is used as a common noun or verb in this sense, like the sentence in this one. So the entity types are totally dependent on the context where it is used. And to resolve the correct entity type, a NER tagger needs to resolve such inherent polysemy of the sentence word. The other major challenge of software domain text are the inline codes. As people post about their programming related queries, many of the Stack Overflow sentence contains inline codes like the function name in the sentence. And these code words may vary a lot across different language and programmers. Such naming variation from different language and coding styles create a lot of unique and sometimes rare code related words. For example, we found 980 unique function names in a set of just 15,000 sentences. Now, you may think that this code word would be identified by the Stack Overflow poster, but in reality, many of the code words are put as natural language text in the post. For example, when we look at the original post for this sentence, the user didn't identify the function name as a code word. In fact, we found 47% of the code tokens were not identified by the users. These code tokens mixed with it, the natural language text contains a lot of informative entities like the library names, class names, function names, variable names, and even the commands to run programs. And extracting the code entity types from such token are crucial for a software domain named entity tagger. To extract these challenging entities from the software domain text, we have created a new corpus and proposed a new NER tagger for this domain. Our newly annotated fine-grained NER corpus consists of 15,000 Stack Overflow sentences To create it, we randomly selected 1237 questions from Stack Overflow's 10-year archive. Then we selected the most upvoted and accepted answer for each of the questions along with two randomly selected answers. This gives us a collection of 15,372 sentences. We identified 20 different entity types among these sentences, including 8 code-related entities and 12 natural language entities. To our best knowledge, this is the first corpus for fine-grained software named entities. To annotate this corpus, we had 4 different annotators. All of them are computer science undergrad from our university, and they had 62% inter-annotator agreement over the 40% double annotated data. Then we had an adjunction phase. It helps us to resolve the inter-annotator disagreement. Also, it helped us to maintain the sanity of our corpus because we cross-checked all the 60% single annotated data during this adjunction phase. Now, to extract the entities from this corpus, we propose a new NER model which is tailored domain for this software domain text. Our proposed NER model has 3 independent components designed to address the challenges of the software domain. Let's look at the model details. It starts with the input text. For each input token, we find its contextual representation. To do this, we pre-train the BERT model on Stack Overflow corpus using 152 million sentences from Stack Overflow's 10-year archive. During this pre-train process, we excluded all the sentences from our annotated corpus. Next, we extract the output of the code recognizer for each input token to find the code-related words inside the sentence. The code recognizer uses the scores from the language model trained on GigaWord and Stack Overflow code snippet corpus. Then we apply Gaussian vectorization to vectorize the language model score. We pass them through a linear layer and concatenate them with first text word embedding. The first text word embedding is also trained using the Stack Overflow code snippet corpus. They are then passed through another feed-forward layer followed by a sigmoid unit, and thus we get the output of each token, which is a binary result indicating if the input word is a code-related word or not. Basically, our code recognizer takes an input word, don't consider its surrounding context, and then captures the character pattern of the word to find its entity type. Let's see how it works with one example. Consider this word QSORT. As a human, when we look at this word, we can easily say it's a code-related word by observing the trailing parentheses and capitalized characters. Now, when our code recognizer finds this word as an input, it utilizes the language model features to extract its character pattern, which helps it to decide that QSORT is a code-related word. Using the similar technique, the code recognizer finds a binary output for each input word. So, for the words in this sentence, the code recognizer is going to output 1 for QSORT, which is a function name, and 0 for all other words. These binary outputs are then converted to a vector by passing them through an embedding layer. Next, we extract the output from the entity segmenter module, which indicates the entity words in the input sentence. This is a simple adaptation of the BERT fine-tuning model with 3 different representations for each input word. Basically, the segmenter indicates that which word in the input sentence are most likely to be an entity word. So for this input sentence, it is going to output a binary value for each word. Then these outputs are converted to segmented vector by using our embedding layer. So we have 3 different input embedding for each word. Now, all of them do not have equal importance for the representation of the final word meaning. For example, QSORT is a function name, so code recognizer vector may have higher weight than the other 2 vectors. How can we do that? To do that, we introduce embedding level attention. Basically, it helps us to emphasize on the embedding that are more important to the meaning of the word. So how does it work? It takes the 3 different input embedding for each word, encode them using BiGRU, and then pass them through a non-linear layer and softmax, which gives us the normalized weight for each embedding. Then we multiply the encoded embeddings with the normalized weight and sum them up to get the attentive word representations. So each of the input words, we have an attentive representation. Then we pass them through a linear layer, which is followed by a CRF layer, which finally gives us the entity tags in BIO format. So for this input sentence, we get that CPP is a language name, QSort is a function name, and QuickSort, the full phrase, is referring to an algorithm name. So we train our model using 9,000 single annotated sentences, and we use half of the double annotated data as our dev set and the rest as test set. We compare our model with 4 different baseline systems. This baseline system includes a feature-based CRF. Then we had a BiLSTM CRF which uses in-domain Elmo embedding. Then we fine-tuned off-the-shelf in-domain BERT and also fine-tuned the out-domain BERT. So among these baselines, we observe a large increase of 10.58 F1 score with in-domain BERT. This performance difference among in-domain and out-domain BERT basically indicates the importance of pre-training of contextual embedding for the software domain. And I would like to note that this is particularly important because there are a lot of polysemy and salient resilience of the context on the text of this domain. Now, when we compare our proposed models software, which utilizes the sentence tail context along with the corpus level context using the code recognizer model, it basically outperforms all the baselines model. And it provides 10.98 increase in the F1 score over the in-domain fine-tuned BERT. So this model works pretty well for Stack Overflow domain. The question is if it can extract the entities from other software text. To find the answer, we randomly selected 143 GitHub repositories and annotated 6,000 sentences from their readmes and issue events. Similar to the Stack Overflow domain, we found that our proposed NER tagger outperformed all the baseline system. Now, to further test the model capability on out-domain data, we compared it with another baseline BiLSTM CRF model, which utilizes the GitHub domain contextualized embeddings. And we found that our model, which doesn't use any GitHub domain data, performs pretty close to the model with in-domain embeddings. So, to wrap up, we propose a new task of fine-grained software entity extraction. We created a new dataset for this task, which is the very first NER corpus of fine-grained software entities to our best knowledge. And we also created software domain word embeddings by pre-training them on the full Stack Overflow archive. And these embeddings are publicly available on our GitHub page. And finally, we proposed a NER model, which is specifically designed for the software domain text. Along with our NER tagger, we also present a code recognizer model, which can find the code tokens inside a natural language sentence without considering its surrounding sentence. And our code and data are publicly available on our GitHub repository. So that's all from my side. Now I would like to take if you have any questions.
Thanks a lot for the presentation, Jeniya. Let me start off with a question. I was very intrigued by reading your paper. In the second page, you mentioned that NER in the software domain is an ideal benchmark task for testing effectiveness of contextual word representations. Can you please elaborate why do you think it's an ideal benchmark?
So when we were actually dealing with the software domain text, we found that it is kind of unlike the biomedical data and the newswire data, because there are really some higher dependency on the context, on the code context, and it is crucial to resolve this context, to resolve the ambiguity and categorize the new words we are seeing. So if I like to quantify it, you will say that when the code domain, like when in the main paper of Elmo and BERT, they said that the contextual embedding provide only 2 F1 score increase over the glove embedding. So glove is basically not considering the context, whereas Elmo and Bird both are considering the context. Similar result was reported for the biomedical domain. So, however, we are seeing a huge increase, kind of 10F1 score increase. So, when we actually try to find the reasons and we analyze the glove prediction versus the bird prediction and Elmo prediction, what we found was that whenever there is a new unseen word, glove is performing pretty bad. It is basically not tagging any of the unseen word correctly, whereas majority of the cases Elmo was able to find it and Bird was doing little better than Elmo. And in our data set, we found that 38% of the entity tokens are new words. And why there are so many new words? This again is going to the programming domain where people can name anything. There can be a new language at any instant. There can, for example, like 10 years ago, there was no language named Go, but right now there is a Go language. There can be a new library, there can be a new API. So all these unseen words are really common for software domain. However, if you have something in your named entity tagger, which instead of just memorizing the previous words or previous entity words, try to resolve what is the context of this word with respect to this sentence, then it is more likely that you will be able to tag those new words correctly rather than considering its global meaning. That's why we think that the software domain NER tagger is a very good test bed for any contextualized embeddings. Does does that answer your question?
Sorry, I was on mute. Definitely. Thanks for answering the question. Royal, do you have questions?
I see. I think that makes sense. And maybe a question that I had based on uh, yeah. So can you hear me? Yeah.
Not
So I was
really.
wondering, did you use any other data sets apart from, or did you consider any other data sets apart
Oh
from
no,
GitHub and
actually
Stack
we didn't
Overflow?
use any other.
I see. Okay. So it was mostly GitHub and
Yeah, I haven't used any other data set except GitHub and Stack Overflow because our focus of the corpus was basically Stack Overflow, and then GitHub data was used as a test case that we are not using any Indopain data set for training. So how bad is the model doing for a new software related data? And we found that it is doing pretty well because it is capable of extracting the entities with 62% F1 score, which I think is pretty good.
that I found based on your code recognizer model is that you use a language model that's trained on GigaWord, right? And
Yeah.
correct me if I'm wrong, but GigaWord is more like I know it's been used for summarization task where you given a text maybe generate headline based on the first line.
Yeah.
And I found it very interesting that you use this particular data set for like a language modeling task and code recognizer. So I was curious as to what was the motivation behind this.
Yeah, this is actually a really good question. So you can think it as giving our model some prior knowledge. So, for example, consider the word sort.
Hmm.
If we are saying just the word sort followed by parenthesis, as a human, you will know at the moment that this is a code word because there is some following opening and closing parenthesis.
Mm-hmm.
Now, if the word is sorting, most likely that's a natural language word because sorting is used as a verb sense, something like I'm sorting this out.
Mm-hmm.
Whereas if I just say the word sort, you will know that okay, it can be a part of the named entity, code related named entity, it can be a part of natural language also. Now,
Mm-hmm.
how we human are thinking that? We read both type of data, kind of the normal words or tokens used in a newsware dataset, as well as we are like in the we do a lot of coding for our work, so we also know the code related work, like usually a function name followed by some parentheses. So
Mhm.
that is the exact thing what we want to do with gigaword corpus and stack overflow code snippet corpus. With the knowledge of gigaword corpus, we wanted to give the model the knowledge for a normal day-to-day code related, non-code related words. For example, the normal newsware words. Whereas the Stack Overflow code snippet corpus, like the language model trained on the Stack Overflow code snippet corpus, is basically having all the knowledge of the all the Stack Overflow code term. You can think them as two persons, one who is specialized in newsware text and doesn't have any knowledge on the code related text, and the other person, which is our Stack Overflow language model, he is expert for any code related tasks.
Mhm.
Now this two person, when I'm giving a new word, I'm asking the gigaword person, hey, do you think it's a normal, it's a newsware word, have you seen it anywhere? And he said that I have seen it with some probability. Same happens to the Stack Overflow person who says that, okay, I have seen it with some probability. Now whom you are going to trust? So the following linear layer is going to take the inputs of both of this one, as well as combining the character patterns from first text, and then finding that, okay, with these two judgment of gigaword language model and Stack Overflow code snippet language model, which one has higher weight or which is more likely. That's
Mhm.
why we needed to include that, because we are not only looking at the code words, we are also trying to find that if this word is not at all a code, or if this word is an ambiguous word, then we are basically outputting zero, because we don't want our system to overpredict.
Okay, yeah, that answers my question. So, Has, did you have any questions from the audience, or did you have any questions?
Yes, there is a question from Swasti Khan in the YouTube live stream, and I guess the question is basically maybe a little more deep dive into the NER model. So it's can you please explain the process of identifying the 20 entity types across 1 million sentences? So maybe we could go a little deep into the NER model itself. Uh, you can share the slides too. Yes.
Yeah, sure. I would actually like to share the slides to answer that. So, yeah, just a minute. Let me. Well, sure, present for now. So, can you guys see my screen?
Yes, yes.
Okay, great. So, here we have some input words, and then for each input word we would like to find them that what is the entity type of that specific word. It can be inside the entity, it can be outside the entity, or it can be the first word of an entity, which will be the B followed by entity tag. Now we actually didn't have any specific like rule that we need to find all the 20 types of entity from each sentence. So rather than we trained our full model with different entity types and then see that what is the output predicted by our model. So there can be some sentence where there is no entity, because that's possible, because it is a natural user generated text and user can write the text in any ways. So the general way is we just fed our model some normal text generated by the Stack Overflow users, and then it gives us the output tags, which will be the 20 entity types. Now, if we ask that how we actually find the 20 different entity types, it was while we were doing our manual annotations. There were different phases. Basically, if the first phase is we randomly sample the sentences and then find that, okay, there are some, these are the entity types possible. And then when we are annotating gradually, we increase the sizes. One interesting example is the HTML tags, we didn't include it initially, but when we were annotating the sentences, we found that HTML, XML questions are really popular in Stack Overflow. And there were a lot of questions for that. And you can't actually put the HTML, XML tag as just a code word, or they are not even the variable names or function name. So we created a new tag for that. So this is basically by the observations from our annotators and adjunctors that what are the possible entity types. So this is the reason after each 50 question annotation, we sit together and then discuss that what is our progress so far, and is there any problem that we need to address. And if all of our annotators and the adjunctor, which was basically me, agree that okay, there is something we need to add, then we go over and added that entity to all the previous sentences. So that's how we find the 20 entities. It's like we started with something, then we go over the annotations, and then started dealing that, okay, if it is enough or if it is not. So that's
Wow,
how we find it.
it seems like a very long process. I'm just curious, and I know, like, a lot of work that goes into like all these top tier conferences. You have to, put in so much effort and do so much sacrifice, and so I'm just curious, how long did it take the whole annotation process? Such a
It
laborious.
was 1.5 year long.
Wow.
So it is particularly because we had our undergrad annotators whose annotation quality is really good, I must say, because all of them are computer science undergrads.
Mhm.
But we kind of lose them in a while during the summer vacations and during the winter vacations. So the full process was kind of lengthy. But we didn't want to sacrifice the data quality. That's why we didn't go for the mechanical Turk annotations.
Mm. And I think a related question around that is, maybe, do you maybe have some intuition or idea on what are some entity types that are harder to extract, among out of these 21? Do you think, for
Yeah,
example,
I have a slide for that.
okay.
So, yeah, actually, if you can see the slide, there are like these are the perform F1 score for all the 20 entity types.
Mhm,
So, if we look here, most of them are having over 70% F1 score, except the inline codes.
mhm,
In our model, we actually added a separate code recognizer to aid this, like the function names, library names, and this inline codes. But instead of that code recognizer aid, it is still at the 65% F1 score. And like I would say that this is the entity which performed worse,
mhm,
because other than that, majority of the natural language entities are over 80%. So, and on the average of the code related entities is kind of 75%. So we kind of say that if we can improve the inline code extraction, it will be really beneficial. Now, if we look here that why this thing is particularly hard,
mhm,
because sometimes people put the function names and say some like commands to run it or a part of the whole line as a natural language text
mhm,
without any markdown. Although we use the markdown as a feature for our segmenter model, but it may happen, apparently 47% time it happens that there is no markdown around it. And there is no markdown around like it, and say our code recognizer also missed it. So basically we have no signal from the model or from the data metadata itself that it can be a possible code entity. In that cases, those inline extraction of those inline codes becomes really hard. So one possible improvement fact is that if we can include the code snippet accompanied by the post.
mhm,
So for example, what we did is we trained a code recognizer over the full data dump of the Stack Overflow corpus. But along with that help, we can also utilize the code snippet accompanied for that specific code. Why I think that may help is because, say, in this specific post, the user might have a code block followed by it, where he actually detailed the functions, and the function name is underscore numeric. So if we can utilize that information and incorporate it somehow in our NER tagger, I think that would be particularly helpful. But we didn't explore it in while developing our model. I think that's a interesting direction of future work.
Wow, this is very interesting because I think this detail is not there in the paper, and specific.
There is only 8 pages we can write.
I mean, this is like a specific treat for our viewers. Very, very interesting. And I see from this particular graph too that the natural language entities can are like generally doing better than the.
Yeah, I would say that the natural language entities are much easier to find rather than the code entity types.
Mhm.
Is because, and I think that for software domain you actually need to know what are the library names or what are the function names to find coherent entities, that coherent NER recognizer, because if we just say all of those are code blocks, that's kind of very big picture. We want to know that okay, this is the all Python works, what are the library names. If, for example, if we want to create an automated knowledge base with all the library names of Python, and if we just run over all the Python question answer over Stack Overflow, we would be able to create something like that. So that's why I feel that these code related entities, although they are hard to extract, are really important.
Right. Oh, okay.
Um,
That's my question.
nice. There is a question from the audience. Naushin is asking if the same set of annotators stayed with this project during the entire 1.5 years of tagging.
Actually, we had four different annotators. Two of them stayed during the full process, and two later joined kind of 6 months later. But pretty much we had the same set of annotators.
Thanks.
I think I had another question, maybe again a little more detail about the tokenizer. So could you, I know in the paper you mentioned there is the SO or Stack Overflow tokenizer and TWO tokenizer. When there are already like some tokenizers available, like from CMU and so on, why did you think it was probably necessary to create? And I think this was one of your contributions to like a new tokenizer. And why did you think, and how is it different?
Actually, this is a very good question. So, maybe there some background I can give how we started this project. We were doing some kind of information extraction tasks from the software domain, and we found out okay, there is basically no NLP tool for this domain,
Hmm.
including the tokenizer. So basically, tokenizer were the step where we started to building one, and we realized okay, we need to build something. So why tokenizer one? The CMU tokenizer and the like our tokenizers are really good, but they are built for tweet.
Hmm.
So when you are going to tweet a domain, it is specifically built to address the noises for Twitter domain. So if there is a dot in between two random words, they just think that this is actually Twitter user forget to put the space after the full stop sign.
Hmm.
Now, if I like I call a function name inside a library, majority of the languages there is a dot followed by the function name or followed by the variable. That's not the only cases. Even in CPP, when you like call a function name, it is usually a dash followed by an arrow, and they separated the full parts, and that's totally makes sense for Twitter domain because most likely those are just user noises, and it is easier for downstream tasks if the tokenizer separate that. But for software domain, it is actually bad because our function names are getting separated, say our library names are getting separated, and we really don't want to do that. So for example, if there is say numpy okay dots sparse metrics or something like that,
Hmm.
I'm just making up the names, but
Hmm.
whatever. So in those cases, say sparse matrix is a function name. I would like to tag it as a function name. Now we are not doing the hierarchical entity tagging for this specific project. If there was hierarchical entity tagging, we can then tag that this whole thing is a function name. NumPy is a library name, and the later is basically a function that is included in the library. But that's, I think, something we can do in future. As a starting point, we tag it as a whole. So if we want to tag it as a whole, we want to keep the word together rather than
Right.
splitting it. That's the part where we actually were intrigued to make a new tokenizer. And I think we also mentioned it in our paper. We started from their tokenizer. So yeah, those are really helpful.
Wow. That answers my question, Jeniya. Thank you.
Okay.
Thanks, Jeniya. I was wondering if you could give a sneak peek into your future work.
Oh, okay. So yeah, I uh, there is no slides yet for that. But what I can tell you is that the next thing I'm doing is particularly because of stance detection from Twitter domain. So one of the examples, something like that, you will feel if you log into Twitter, you can see random tweets like that. Hot water mixed with some honey or something is a cure for coronavirus. And there was some crazy tweets like marijuana will be a cure for coronavirus. So all these things are rumors. Now, what if there is an automated system which can actually find these rumors versus non-rumors? There are already multiple data sets for it, but are basically planning to create a larger data set with respect to this domain. For example, all the previous data set I came across with covers 5 to 8 events. So this is kind of skewed. So it is not actually covering, either it is covering all the political rumors or just the medical rumors or some kind of natural disaster rumors. So our next goal is building some systems which will be able to cover different dimensions of the data and thus extract more like diverse entities in the corpus. So why we think that will helpful? Because the more diverse your corpus is, you can actually test the ability of your model further. Because if the test set is not diverse enough, you may get a false interpretation of the whole thing that okay, my model is getting a 90% accuracy, but the whole data set is just for disaster related rumors. So then that data set is most likely fail, or will most likely gonna fail in different political rumor detection one. So instead of having different like pieces, for one for political one for disaster one, and one for some medical rumors, we would like to do some random sampling and then collect the like basically utilize the Twitter fire hose to find that okay, because we have lots of data, I would like to utilize that to build the stance classification further.
Wow. Okay. Awesome. So if there are no further questions, I think Suhas is gonna ask us some. Uh, this is gonna be like a game, I think, where he's gonna ask us whether he's gonna give a use case and then ask us whether it is solved by GPT-3 or not. I don't know. Suhas, do we have more questions for you?
um, I don't think there are any more questions from the audience. So I guess let's address the elephant in the room, which is GPT-3. I don't know that like there are a lot of people who are talking about no code and software developers out of work and everything. But by the way, a plug
I don't
for
believe that so yet. Because well, I mean, particularly for us, we don't even know that exactly which part of the model we are going to develop. We know that we are going to develop something good. So I'm not sure is GPT-3 yet there. So,
Definitely.
for example, any research project or any machine learning project, you kind of develop it iteratively based on your say everyday work. So I'm glad that GPT doesn't have that power yet.
Yeah.
Yeah,
Cool.
definitely. Just using this opportunity to plug our future events. So we'll be having a deep dive into GPT-3. I will be going into the paper and along with a few other guests, and we'll try to disentangle the substance from the hype, basically.
Sure.
But for now, our NLP stream wouldn't be complete without a cheesy ending to the video. So I would like to ask, play a small game, a cheesy game called GPT-3 or not. So basically, I will say a capability, and you can guess, and the audience too can guess whether GPT-3 has solved this, or basically whether someone has demonstrated GPT-3 doing this or not. So the first one is someone described a data set and the required output, and then GPT-3 generated a Keras model for it. Yes or no?
Jeniya, what do you think?
Uh, Probably. I'm not sure. Most likely, it can be or may not be.
Yeah, I think it probably someone probably did. I'm not too sure, but uh, what do our viewers think, and what is the right answer to us?
Let us. I think there is a lag uh, for the viewers in the YouTube. So Sean Godbole says not likely. He's very confident about that.
Hmm.
Um,
I think in general for all possible task descriptions and output, maybe it is harder, but someone might have done it for like one particular task, one particular simple task, maybe.
I think there is a lot of code out there that kind of this particular subset um, is amenable to GPT-3. And I think, yeah, there's actually a demo. Someone actually did it. Of course, it won't work all of the time, but I think what we have to keep in mind is that if GPT-3, if you find a counterexample and say GPT-3 can't do this, it's also possible that you are not priming the model well. On the other hand, you see it's succeeding, but it's maybe in a few cases where it has seen a lot of training data on that. So, yeah. I think the second one is given a description of a chess game and layout of a chessboard, GPT-3 generated code for the chess game that can play the chess game.
So, so
You mean designing the full user interface?
Yes.
and a full game.
Yeah.
I think that is too much for the model.
This is too much hype. Yeah.
yeah. Yeah, I guess so too. The next one, again, because I used to be in the information security field. So, given a description of a security vulnerability, GPT-3 generated code for malware.
Yeah, I'm not that maybe.
Hmm.
Uh, Maybe no, it's not. I'm not sure. It should not be doing that for
Yeah.
ethical reason. I'm not like even without going to the model capability. I think for ethical reason it shouldn't do that. And yeah, that's the thing because it's not fair.
I would think the same. It's probably not doing it.
Yeah, yeah, and that's great to keep ethical concerns in mind. So that's a great point, Jeniya. And finally, given a program, GPT-3 can generate a textual description for that program.
Hmm. Is this even any program or?
You mean generating the comments?
Yeah, generating a textual description of what the code is doing.
I think if it is a simpler code, the GPT-3 might be able to do it. But if it is
Mhm.
a harder and long, very long code, say some kind of named entity, long named entity tagger, I don't think it will be able to do it.
Yeah, I
Yeah,
think my answer is the same. That if it is a very simple program like Factorial or something, it might generate the description, but if it's like a really hard program, it probably wouldn't.
yeah. Okay, I think we are about done there. Thanks a lot for this very engaging session. Um, to the audience, thanks for participating. I so we have a bunch of events coming up in August, including the ACL 2020 Best Paper Award winner, as well as a deep dive into GPT-3. So um, watch this space. Thanks a lot.
Okay.
Um,
Thank you.
okay, thank you. Um, we'll go offline now.
Okay. Bye.